My name is Leslie Gina. I work here at PRC. I'm the director of the art programs. So I make sure that all the art programs are running smoothly and all the volunteers are doing what they're supposed to be doing. If ever you're interested in an art class, let me know. This presentation is about 3D printing, which we just very recently got involved in. Right before the summer started, I got an email from a woman who has two twin sons who are in high school, and they are very into 3D printing, and they wondered if we might want a 3D printer donated to PRC to use. So these guys spent their summer internship money that they made from their summer internship on they spent that money to buy us a 3D printer that they donated to PRC. Very, very nice young men who did this. And then they also, at the end of the summer, taught a little 4-week crash course on 3D printing. So it's great to have those guys help us with that. I am not the expert that they are at all. I just started kind of learning about some of this stuff with their help, but also a little on my own. So I'm just going to I'm going to explain kind of how the 3D printer works, especially our model, because that's the one that I'm familiar with. And I'll show you a little bit on the computer of the 3D modeling software. I'm not going to get too involved in it because it is a little intimidating, but I will do the best I can to answer questions. The printer that we have that they donated is a consumer use printer. So it's not an industrial printer. It's very small and portable. And it stays in my office, and when we need it, if we ever need to bring it downstairs, we can. But it works off, it's wireless, and it works off a flash drive. So any files that you want to print go on a flash drive. So that's why we keep it in my office, because if somebody makes a file down here that they want to print, we can just transfer it up to the printer from the flash drive. So this is a model that PRC has, and I'm not going to go into really other models because this is the model that I'm familiar with. Obviously, you can't print anything bigger than this little print plate here and this little square area, so it does just print smaller things. There are printers in the industrial world that print giant things like big parts for cars and things like that, trains, whatever. Ours is not, meant for that purpose, right? First, I'm going to explain exactly what 3D printing means, right? So we're used to printing on paper, a two-dimensional print, I guess we'll call it, on paper. So if you're printing like a photo or a file or whatever, we all know how that works, right? With a three-dimensional object, you're using successive layers of material that are created under the computer control. So they can take on any shape because it's three-dimensional, and they're produced from an actual 3D model. So if you're printing like a photo, you've got a file that the computer can read the information and then send it to the printer, and it knows how to print it. And on a regular old printer, it prints in layers. If you ever watch your printer, it goes in layers. So if you're printing words or something, you see the first line, then the second line, then the third line. It is actually the exact same for the 3D printer. It prints in layers. Ours prints from the bottom up. So for example, this little vase, and I'm going to pass these guys around, it would have printed from the bottom up in layers. It adds material. In our case, ours can only print with plastic that I know of. It takes a special kind of filament. There are 3D printers that print with stainless steel, with chocolate, with all kinds of different things. So you can technically 3D print out of any kind of material that could be heated and cooled. So like you can see people print shoes that you can actually wear, candies that you can eat, little parts for machines. Again, our printer is the Cube, and ours only prints up to 2 colors at once. So right now we have black and neon green. I think that's what came with it. The boys just called me and asked if we wanted any more ink. The filament things, I think, are about $45 or $50. They last a while if you're not printing a lot. But it's, they get a little pricey, so we didn't want to order a ton at first. But they just called and said, we have extra money. Would you like us to order another one? What color? So we're getting red next, which is exciting. But the files, much like a photo, right? So if you're printing a photo, it has to be a certain kind of file type, right? Maybe a JPEG, maybe a TIFF, whatever. For the 3D printer, it's a certain kind of file type called a .stl, and the .stl has to be then, for our printer, has to be converted with the Cube app. So our printer has a specific app that comes with it. It won't print anything unless you've taken the file, put it in the little app, and converted it to make sure that it can read it, okay? So most printers can read, you know, whatever file, like if it's a JPEG or whatever, but you do have to kind of install a driver, you know, on the computer for the printer. In our case, the driver is kind of that app. That app will take the file that has to be a .stl and then make it into a Cube file and print it. So that's just kind of, I think it's probably the company's way of controlling everything that happens with the printer, but that's how it does it. So again, it's called additive manufacturing. When it's building things layer by layer, it's called additive manufacturing. And the file is digitally sliced. The filament that we use, there's two types of filament. There's ABS and PLA. I don't know much about ABS because the way the guys described it, it sounded like who would ever want to use it. It sounds like it's more chemically based, whereas the one we use, the PLA, is biodegradable plant-based. It doesn't smell. It's not, you know, putting chemicals out there. And it's apparently a lot easier to print with. You get a smoother kind of print job from it, and it takes less time. So I figured, well, yeah, let's go with the PLA because that seems pretty good. But it's just a plastic, kind of comes in the spool, like you can see, and the printer will heat it up. As it's going through the jets, it'll heat it up to kind of liquefy it so it can get through the two jets. And then it starts forming the layer, and it instantly starts cooling it to harden it. So you would think that when you touch it, when it's coming out, it would be really hot, but after like a few seconds, it cools down pretty quickly. You still aren't supposed to touch it while it's printing, of course, but it cools pretty quickly. So that's nice. It doesn't get, then the machine itself gets hot, but it's not too bad. So there are several methods for actually making a 3D print file. You know, so if you're, let's say, I don't know, has anyone ever used Photoshop by chance or anything like that, like a photo editing thing? Yeah, right. So that allows you to create, you know, an image, a photo, or something that you can then print, right? There are programs that allow you to also create a 3D model to then print. One of them is Google Sketchup. After PowerPoint, I'll go ahead and open that up just to show you. But a long time ago in college, there were some 3D modeling programs that I used to make some things. They use it a lot for like animation and that kind of stuff. And it's interesting because you are designing an object on three-dimensional planes, right? So you have to think of how it fits within the space around it, which is really hard to do on a two-dimensional screen, right? You know, you're looking at the screen trying to figure out, does this go all the way around? Does this meet that part? And you know, so I think that that's a limitation with some of the software. There's probably, you know, for people that are doing this in an industrial field, there's probably a way to see it a little better than on the screen. But I think it can be a little challenging, but it's interesting to see and play with. So I will kind of play with it towards the end, and we can see if you guys want to open it up as well. The software that we use is called Google Sketchup, so it's a Google program, and it allows you to create shapes and then stretch them, you know, make them smaller, extrude them, punch holes into them, and make them an actual three-dimensional object that then you can convert to the proper file and then print. So there's a ton of programs out there. Google Sketchup is free, so of course PRC, we like to do if we can get something free, it's nice, and it works well, and it's easy to use. Again, I just went with the recommendations of the guys that, you know, donated the printer, so they recommended SketchUp, as well as a program called Sculptress, which is kind of fun to play with. Obviously I'm an artist. I went to art school, and Sculptress basically gives you a ball of clay that you can like mold. So it's a lot of fun for me because I can play with it and, you know, using the mouse. And I'll show that too because it's just kind of fun to see. Both those programs, then we have them on all the computers, and both those programs make a certain file that then we have to convert, but I usually do that in my office because I have the conversion program in my office. We didn't bother to put them on the computers down here because the converting is something that we can do kind of, behind the scenes. But they do create a file that you can export and save, and eventually, once it's converted, it would be put on the flash drive and put into the printer. So those are the programs that we use here. Another way to make a 3D printed object is to scan something. So you can scan an object and turn it into a digital file. So there are different desktop scanners that can do this. The boys that taught I'm just going to say them by their names instead of calling them the boys, Matt and Zach, when they came to teach their workshop, they used a 3D scanner to scan the busts of the students in the class. This guy happens to be a computer furbishing volunteer. His name is Jim. Some of you may have met him. I will pass that around, but you can see it really, if you don't know him, it's not going to help, but it looks a lot like him. And basically, they used, so if you guys are familiar with an Xbox 360, it's a video game system, and it comes with a motion sensor. So these days, the cool video game technology is there's a motion sensor, so you don't even need a controller anymore. So remember back when we had the little Atari and the one little joystick? Yeah. Those are becoming obsolete, and now people are using a motion sensor that if you're playing a game, you're acting out the motions, right? I know, that's what I said when I first saw it. So, that's where technology has led us, but as a result, that motion sensor can act as a scanner, and it can scan an object, much as your regular photo scanner would just scan the photo. It knows when the paper is on the bed of the scanner, it knows how to do it. This will scan something three-dimensional. So if you have a little object, it'll scan it, and it will turn it into a 3D rendering. You need special software to do that. We're not there yet. We don't have that yet. But the Xbox Kinect is something that people sometimes have in their houses that then they can use to do this. There's also other three-dimensional scanners that will do the same thing. But basically, Matt and Zach had all the students sit right here in this chair, and they took their Xbox Kinect, which is a little device, a little bar, and they circled them, right, as they're sitting here, made sure that they got every part of their, head and shoulders. So one of the twins was, circling the person and scanning them. The other one was looking on the computer to make sure all the information was being transferred right, And it actually didn't take them very long. They're pretty good at this. They do it a lot. So that, for them it was pretty easy. But basically, they did this little chicken. The little chicken they then printed into a little red thing, much like that bust of Jim. We scanned him, and then we printed him out in neon green. So that's the Kinect. You can also do an entire person. So here are the twins. One of them is scanning the other one. And it turned into a little 3D model, a little tiny Matthew, it's about this big maybe, that they then printed. So you can print a full body scan. You can probably, if you have a big machine, you can probably print out an entire life-size plastic version of yourself. You just have to be able to stand completely still, right? So all of our students that day had to just sit still for just a few minutes to do their bust. If you are standing and being scanned, obviously you have to be still a little longer than that. But you can go around the whole body again and scan it, and then the file will convert over to a 3D file using the software that you have. So it's a kind of cool technology. There is a lot of interesting things you can do with it. It's used for, the main purpose, and I think the reason that a 3D printer was created was for manufacturing purposes, right? So it's a cheaper way to create little parts or, different parts of things, or something that you need to rapidly mass produce. It's a cheaper way to do it, and it can be a faster way to do it. So that was kind of the first use of a 3D printer. But nowadays, you can do a lot with them, right? Like I was saying, you can make food out of it. You can print out a chocolate. People are even using it. I think there's some research for using it for skin grafts and things like that, printing, with a skin-like material. I mean, yeah, it's a lot. A lot of artists use it. People use it for jewelry, you know, wearable stuff, home stuff, you know, lamps and all kinds of things. So there is kind of a lot that can be done with it, and I think now it's becoming more of a technology that people are interested in and interested in learning more about. So you're seeing it pop up a little more. I think a few years ago, maybe it wasn't as common to see it, but now some libraries are starting to get 3D printers, like the Glen Ellen Library has one. I just read that they did a contest for kids where kids could design something and print it, and whoever had the best one won, or, you know. So it's kind of, it's starting to become more of something that the public use can get into and use, which I think is really cool, because the first time I heard about it, probably, it should have probably been longer ago, but it was not that long ago. And there's a studio in the city of Chicago where I live downtown, and it's called the 3D printer experience or something, and they would allow you to come scan something, or, you know, create a file. They'd create a file for you and they'd print it, and so it was a company kind of doing it for you, and that's how they stayed in business. But now there's these smaller models of printers. Back then it was just kind of the bigger printers. It was probably only like 5, maybe 10 years ago. Now there's these smaller, easier, portable, you know, more meant for the home models. So I think more people are starting to realize, oh, I can just get one of these printers and learn some of the stuff and do it myself. We were excited to get it for PRC because of the art program could create some fun stuff. But also Jim, the green, the green-headed guy that's being passed around, he mentioned he wanted to take the class because he thought in computer refurbishing, when they're doing that program, sometimes there are parts that they need, right, that they may not have access to fix a computer, and he thought, I could print a little plastic part and it would work just as fine, you know. So he was thinking from a standpoint of that manufacturing thing again, printing a part that you might need. You can print, let's say, you know, if you've ever bought something at IKEA or really anywhere, they give you tons of little screws and tons of little, you know, all that little stuff. Okay, you lose one, then that's it, because the thing is not going to stay together without that one little piece. You could technically then scan one of the pieces and print an extra piece, you know, and then you'd have an extra piece. So there's things like that that I think make it good for home use in that way. Some people, you know, might have something that they bought a long time ago and they don't, you know, they can't find the part for it because it's vintage or whatever, you know, and then you can make your own part by scanning it. Or if you're really savvy, you can try and, you know, actually make it in the software. But scanning it makes it so that you can get an exact, pretty accurate replica and then print it. So those are kind of the uses that it's used for. Are there any questions right now? Yes.
What is the cost of that print?
Yeah,
as
right.
well as the filament that you have to buy?
Yep. Okay. So the filament comes in these little rolls. So on the side here, these are our filaments. So there's green on this side and black on this side. Ours only prints in 2 colors. Some print in more. The filament, I think it's like $45, $50 for one. And again, you can only print small things on this, so it does last for a while. So it, like little things, like that little green monster guy I passed around, that's probably like 10 cents to print, probably, you know. So it's, you know. The printer itself, this model I think was $500. That is the cheapest probably you can get, yeah. So I know there's other models that are a little more advanced maybe than this one that look similar, that are closer to 1,000. The guys said that ours was about 500. That is definitely that's probably the cheapest you can get. So they are costly. The fact that libraries have them is pretty great if that's starting to become a thing, because then you can go to your library and use one, or, you know, you can, and if people that belong to PRC can come and, you know, if they've got something they need to scan or print. We don't have a scanner yet. We're working on that. But if people are, you know, so the people that took the class were making little models of things like gifts for their loved ones, or little things that said somebody's name, or, you know, little plaques, and so that they could print them to give as gifts and things like that. The 4-week class we had was pretty quick. I think people definitely wanted a little more than 4 weeks, but the guys, they're high school students, so they had to go back to school in August, so they didn't get to stick around, and now they are, you know, in school, and we can't probably get them back till maybe next summer if they're at all free then. But yeah, so that one was about 500 to really answer your question. Yeah.
How many cartridges would it hold?
Just the two. Yeah, ours only does two.
You want to play with more colors, but you can't.
You can't. You can only print in two. Right. So that's the limitation of ours. I think there are printers that probably have, a ton. Some of the bigger ones. But yeah, ours does two. So we're starting simple. The PRC. Yeah.
So because of the filament,
Yep.
it all comes out plastic.
Right.
Right.
Yep. Ours now, but that I don't know if ours would take another kind of material, like another filament roll of some other kind of material. I don't think so. I think ours is really just designed to print with the plastic filament. But yeah, it'll all be plastic. So that thing that the models I passed out, that's the texture. And you can see on those models, where are they? If you got to take a look closely, you can see there are little tiny lines. They're hard to see, but those are the layers that build up the plastic, and it builds tiny, tiny little layers that then work upwards. So it takes Jim, as tiny as he is, he took 2 hours, I think, to print. Yeah, because it's building up the tiniest little bit of material. And I'll show you when I get it going. This little guy takes, I think, like 20 minutes or maybe half an hour. It just because it's the tiniest bit at a time. You can change, much as on a regular printer, you can change the quality, right? So you can do it if you want to print something fast, like if you want to print a document out fast, you put it on fast rather than best or whatever, the quality types are. You can do that for this. It'll limit how much it puts in these. So they're kind of hollow, but on the inside, and I don't have a good example because we don't have something that is really open, but they do like a cross-hatched pattern on the inside layers that you can't see. So it's kind of like a filler layer, if that makes sense. So it's not totally hollow. It's got some structure. So you can, I think when you change the settings, it will do less of that kind of filler layer. I haven't played around with it. I've just kept it on the best one. But it'll do less of that filler layer so that you might see the lines a little more, if you're doing something fast just to test it. You'd see the lines a little more and it wouldn't be like as smooth. Other things too, like, when you've got a part, chins are always a problem, and noses. If you've got a part that's coming out a little, as all of our chins and noses are, sometimes they droop a little or they get a little extra material, and you can just clip it off. Chins turned out pretty good, but there's some things that the way they are constructed need a support. So I printed out a little. Oh, I should have brought him. He's at home. I printed out a little bust of Yoda, and Yoda has ears that stick out, and so if I had to put little supports. So the program will let you add a support, and it's just a little line that comes down to hold it to the bottom of the plate that you can clip off later. If I didn't do that, his ears would probably, as the plastic would start to harden, would probably just get too heavy for the thing and droop, and he'd look like a little dog or something. So there are ways to make it so that things keep their shape. They're called little supports, and they clip off. We have a little pair of pliers that came with the printer, and you just clip them off. So I haven't had a lot of experience using the supports. I try and put things that are flat because I'm still getting used to it, but these didn't need supports because it's pretty small, but something like this wouldn't need it because it builds up and it gets smaller. Same with this little pencil part. These little arms aren't coming out enough to need it. Any other questions? Yes.
Is that program involved any copyright? Because we printed something and make it out of it, so any copyright, we violate the copyright?
Good question. Yeah, not that I know of. I mean, so if you had something and you like scanned it and print, right? I don't think there's issues with that because it's not copying it in the exact way. It's always going to be a little bit different in the way that you're processing it through the printer.
Different bus too. Okay.
Yeah. So I've never heard of that being an issue. There is a website. Well, there's a lot of websites, but you can actually, if you don't, skipping the trouble of scanning something or making your own kind of file in Google Sketchup or Sculptris or whatever, you can go online and find models that people have put uploaded on the internet, that you can then download and print. So people share for free a lot of files that either they have made, either they've scanned something or made it in a program. There's a website, I don't think I put it on there, but it's called Thingiverse. Thing, the word thing, then then VERSE. So like universe, but Thingiverse. If you go on Thingiverse, you can search for anything, and they'll have little 3D models of like just about everything. That's how I found the little Yoda bust. I didn't make him. And I think, I don't know if this vase came from there. I can't remember, the boys made that. But so people will share all kinds of different files, 3D files that they've made that you can then download and print. In our case, so it downloads as that .stl file. That's the proper 3D print file. In our case, we have to do an extra step of then taking that STL and putting it in my Cube app. And I've got it on my phone, I've got it on the computer, my work computer. Putting it on that app and then converting it to actually print on the printer. So if I just take the STL that I downloaded from Thingiverse and I put it on the flash drive, it won't recognize it. It has to go through that Cube app and then it will recognize it. So probably not all printers are like that. Ours is like that. But yeah, so you can find a whole bunch of stuff. Little toys, little, like all kinds of stuff. My husband collects, he's really interested in mid-century modern chairs, and so I printed out a little Eames lounge chair. It's a kind of chair from, I don't know, the 50s or whatever. And it's a little tiny model of it. And, so you can find all that stuff when you're a novice, like I am. You can find all that stuff online rather than, make it. So that website is a really good place to go for things like that. And they might have, if there's a specific part or something that you are looking for, always check online and see. There might be a 3D model out there so you don't have to scan it, there might be one out there that you can then download and print for free, because the Thingiverse is all free. A lot of them are free. You just have to make sure it's a trusted file or whatever when it is downloaded. Yeah.
How long does it take for it to dry and harden, or?
It hardens really fast, actually. Excuse me. As soon as it starts to add extra layers on top, it starts hardening, like pretty automatically. So when it's done, the whole thing is totally hard. And you use, and I'll show you when we start in a minute, put a little glue on. This stuff is really strong, and I'm going to have to research if there's one that's not as strong, but when you put the glue on the base of the plate, that way it keeps whatever you're printing kind of in place. If you didn't put the glue on, it might kind of move around and then things would get, wonky, but a little bit of glue will keep it on. But then this adhesive is so strong that I have to use this little scraper and I have to really get it off the plate, because it really sticks to it, which is good, but then it's just kind of difficult. When you've got something tiny, this little guy, he was sticking right in the little part of glue that I had, and so it took me a little bit to pry him off. But it hardens, and it really hardens, to the point where it's, pretty strong. I mean, you could, it would take a lot to probably break these. I won't try. But, so, instantly. And then it takes a minute for the printer will tell you the jets are cooling, please allow time for the jets to cool, but it takes a few minutes, and then it's pretty ready. And you can soak the whole base. So when it's done, this base comes off and your thing is stuck on there, and you can soak it in some water and it will start to come a little loose, so you don't have to be picking at it so much. Would you guys like me I can open up Sketchup just so you can see. Would that be nice to see? Okay, good. Okay, so say start using SketchUp. Okay, so I'm gonna not do a whole lot with this because it gets a little intimidating, but can you see? Okay, so my mouse is on this tool up here that is green and red, and it's called the Orbit tool. See, it's next to the hand there. So SketchUp puts this guy here, for you to use as a reference when you're creating something. He's just kind of there as a reference. So if you click on this Orbit tool, and you can see now your cursor is that Orbit tool, right? If you click and you start moving, you can move in all different directions, so you can see the different planes, right? So you can move from top to bottom to scroll and see the top of his head. He's flat. He doesn't have a lot of dimension. but things that you create will. Does that make sense? Sort of? Okay. Yeah, again, this stuff gets really confusing, so I don't want to go too crazy with it. Let me see. Okay.
It's easier to see on the house than on the man because
Yeah, yes, that little demo they're giving you on the right is a lot easier because that house actually has dimensions. So let's make something and we can do it with that. Okay, so how do I describe that? It's like a little box with a line. There's a little arrow, right? Let's try a circle. Okay, so you can scroll down and it gives you different shapes, right?
Right.
So click circle. You've got like a little pencil tool, which we've seen in some programs. When you drag it and when you click it and you drag it, it's going to start to make like the diameter of the circle. See how mine is going? And when you let go, it's going to make an actual circle, right? Now, this circle is still flat. Whenever you draw something in the program, it's flat. So if you ever use like Microsoft Paint or even Microsoft Word, I think you can do it. You can draw something with lines or a shape and it'll be flat on the page. This is the same way. It's going to be flat. But now if you take that orbit tool and you go around, you can see, even though it's flat, you can still move around it. I'm going to just show you the simplest way to make it have 3 dimensions, okay? Next to that circle tool, there's this push-pull tool. See that? If you click on that, your cursor will then be that push-pull, that's hard to say, push-pull tool. If you click on your circle, click on it, hold, and then pull it out, it's gonna drag it out. Yeah, it's like magic. Then you can go back to you can put it wherever you want, then you can go back to your orbit tool and spin around and you see, oh, now it's a sphere. There's an eraser tool, right, next to the pencil, next to the arrow there.
oh,
Yeah, I just erased mine, sorry.
Oh, that's it. No, that's good. What's a little different with the eraser tool than maybe some other like paint programs you've used is you have to erase all parts. So you have to start with the line. You have to do both sides, I guess. So you just kind of like keep clicking on stuff until it's all gone. That's what I do. Another thing that I learned, so if you get too zoomed in and you can't see everything on your screen, your track button on your mouse, up gets smaller, zooms out, rolling it down, zooms out, rolling it up, zooms in, right? I'm going to go ahead and erase that guy. Something else I learned that was kind of helpful. Let's say I want to put a circle on top of this circle. See how it says on face?
Yes.
And I'm just going to tell you that the guys, I still have to ask Matt and Zach exactly if this is right, because I've tried to make things like this and it hasn't printed well. But on face, I think, means that what you create is going to be attached to the face of your other object, right? So I think if I push this out, it should be attached. Yeah. So that's how you would build something up. You have to make sure it says on face. I think when you wave your cursor over it, it'll give you the option, and as long as it says on face, you can lay it there. I think you have to be right above whatever your original object is. But, so say I wanted to then put a little rectangle on face. There's my rectangle, and it said on face. Now that should be, yeah, okay. So that on face is how you get things, it's how you make sure that things are, you know, sticking to each other, I guess we'll say, for lack of a better word. But this is kind of complex, right? Like there's a lot happening. And I found that I would get lost if I was trying to add too much. I would get lost in, okay, what's connected to what, and how is this connected to this? You know, then I'd suddenly have something floating off to the side and not know why that's floating, and you know, so it's definitely different working with 3 planes. Let's really quickly. You can close out of that or minimize it. Let's really quickly open up Sculptress. There we go. So that's your ball of clay. This is why I like Sculptress. All these tools on the side, crease, draw, flatten, inflate, all that stuff, you can just play with. You run over the surface. Oh, that's not doing anything. Hold on. There we go. So that crease is going to crease, and the more you do it, the more it's going to crease. Again, I've only used this a couple times, so this is all kind of stuff that I've just played with. But it's kind of fun to just play with some of this stuff. I don't know why the pinch doesn't really do anything.
Yeah, it's not, is it?
I know. The crease is good. That really gets in there. So that's just essentially, rather than drawing and stretching the shapes, you've got the ball of clay that you can then mold into whatever. So those are the 2 programs that we have that do that kind of stuff. You guys are welcome to play with them. It's $12.25, so I'm going to go ahead and get the printer going so you can just see it as it's starting to print. You guys are welcome to play. Yes.
You know how much the software runs?
Free. That's all free. SketchUp.
Here. Oh, it's free?
Oh, yeah.
So I can put it on the computer I get from you?
You sure can.
And Leslie, what's the policy of people wanting to do a 3D model if they want to try it out here?
So they are welcome to try things out and play. They can then contact me if they want something printed. I'll check out the file and convert it. And when I convert it, I'll be able to see if it's printable. So I'll let them know, okay, no, actually, this needs to be edited or whatever. But yeah, as long as they just let me know, I will let them know when I can have it printed. I'll ask them what color. It doesn't have to connect to a computer or anything like that. It literally has one button. That is our on button. And it really does direct you through everything. This is a very user-friendly model. So touch screen. There are 2 paths you can take, I will say. You can do print or you can set up. I'm not going to go through setup right now. It's all kinds of different things that we don't need to see. But if you want to print something, then your flash drive that has the file on it, there's a little slot for the flash drive, and it comes with a flash drive, is there. You can hit print, and everything that's on the flash drive should come up. So you can scroll through all your different things. I'm going to go to that little monster pencil pot, that little green guy. I'm going to go to him. You can see him on the screen, and you hit print. It's going to tell you, put some glue on there. I just do like a little zigzag. If you coat the whole plate, it's too much, and it takes forever to get it off. So I just did a tiny bit there. It depends on what you're printing. If you're printing something bigger, you can put a little more on. You hit that check mark. It's going to warm up. It's going to take a minute. And I won't print the whole thing because it'll take us past 1, but at least you can start to see as it's doing the layers. This one's really small, so it'll build up a little quicker. If I was printing good old Jim, who's a little bigger, it would take a little longer to get, you know, up because he's wider.
Where are those sold? Are they sold anywhere where printers are
Amazon.
sold?
Yeah. Well, no. I think Staples and Office Depot are starting to carry some models. The website is Cubify, but Amazon really is probably the best place to get stuff like this.
How long did it take to print the thing in your hand, that bust?
2 hours he took, probably 2.5. Yeah. So something very tiny, so you can imagine something bigger, it's going to take a lot longer. So I want each of you to take a minute and look closely at what's happening. You come up and look closely because you can start to see the layer forming. But really, if you want to get closer, go ahead. So it's making this bottom shape here, and it's going to... Yeah. Can you see it in there, Pat? Yeah. It's a little, yep. So you imagine how thin that is. It has to build up from there. That's why it takes half an hour.